Okay, students, if you're watching this video, then either you needed some help on your homework, or you're watching this to see if you got the even ones right. Either way, I would encourage you to not watch the entire video unless you need to. That's fine. But just watch the ones that you've missed, or just watch the evens to check your answers, whatever you need to do. Let's start off with number 11. All right, let me get my pen working here. Number 11. 11 times 11. Let me read the instructions. Write a conjecture, or in other words, an educated guess, a hypothesis, if you will, based on what we observe. Well, 11 times 11 is 121. 111 times 111 is 12,321. And 1,111 times 1,111 is 1,234,321. Now, I see a pattern. I see when I take 11 times 11, I get 1, 2, 1. And then notice I added a 1 here, and I added a 1 here, and I got 1, 2, 3, 2, 1. So here I went up to 2 and then back down, 1, 2, 1. Here I went up to 3, then back down, 1, 2, 3, 2, 1. I added another 1, I added another 1, and I go up to 4. 1, 2, 3, 4, and then back down, 3, 2, 1. So here's my conjecture. I'll bet you if I add another 1, so it's 11,111 times 11,111, I'll bet you I'm going to get 1, 2, 3, 4, 5, and then back down, 4, 3, 2, 1. And if you type this into your calculator right here, you will see that is true. Okay? So you saw a pattern, you made a conjecture that this would be the next answer in that in the sequence. Okay, let's take a look at number 12. All right, here we go. 3 times 4 is 12. Then look what they did. They added a 3 here, and they also put a 3 here in front of the 4. All right, so they added a 3 here and a 3 here. 33 times 34 would give you 1,122. And then they added another 3 here and another 3 here. Just like they did up here, they added a 3 here and they added a 3 here. And if you take 333 times 334, you will get 111,222. Now, I'm seeing a little bit of a pattern. See this 12? When I added a 3 here and added a 3 here, my answer was in such a way that I have a 1 here in front. Here's my 12. And then notice there's a 12 right in the middle. And I added a 1 here, and I added a 2 there. All right? Well, same thing again. Here's 1, 1, 2, 2. Here's 1, 1, 2, 2. I added a 1 here and a 2 here. So I'm seeing a pattern. So I'll bet you if I put 3, 3, 3 like I had here, and then add a 3 like I'm supposed to, and then 3, 3, 4, and then add a 3 right here like I'm supposed to, like I've been doing all along, I think my next answer would be, instead of having 3 1s, I would have 4 1s. And instead of having 3 2s, I'll bet you I would have 4 2s. And if you type that into your calculator, you will see this is accurate, okay? So you made a conjecture, all right, based on what you saw. All right, let's take a look at number 13. Okay, number 13 says the product of an odd number and an even number is blank. And the directions say complete the conjecture based on the pattern that you observe. Well, I didn't copy all the problems down, but if you'll look in your book, you'll see that it says 3 times 6 is 18, 5 times 12 is 60, 14 times 9 is 126, 11 times 23 is 286, negative 5 times 10 is, or times 2 is negative 10, etc., etc. I'm not going to read all those to you, but if you'll notice, I'm going to write the first one down. If you'll notice, in every single one of those problems, one of the numbers you're multiplying is odd, one of them is even in every single one, and your answer in every single one is always even. So that's my conjecture. Look in your book, would you? I want you to read number 13 kind of to yourself as I read it out loud here. The product of an odd number and an even number is even. It's always going to be even. In every single one of those examples, we can see they get an even answer out. Okay? All right, number 14. Now this is going to be interesting. This is going to be a difficult one. The sum of three consecutive integers is always 3 times something. Okay? The sum of three consecutive integers is always 3 times something. Let's see. Let's just pick 3 consecutive integers. We'll use the one in the book first. 3 plus 4 plus 5 equals, and then it's 3 times something. 3 times 4. Is that right? 3 plus 4 plus 5 is 12, and 3 times 4 is 12. So yes, they are equal. All right, that is true. Okay, so let's pick 3. I'm going to make my own. I'm going to make my own. I'm going to say 20 plus 21 plus 22 equals, and guess what it equals? 3 times 21. If you don't believe me, type that in your calculator. Type in 20 plus 21 plus 22, and then 3 times 21. You'll see they're equal. You get the exact same number. Let me show you another one. Let's try 88 plus 89 plus 90 equals 3 times 89. If you type this into your calculator, and then type this into your calculator, you'll see they equal each other. Are you not seeing the pattern? Whenever you add 3 consecutive integers together, they will always equal 3 times the middle number. What's the middle number? 4, and it was 3 times 4. What's the middle number? 21, 3 times 21. What's the middle number? 89, 3 times 89. That's pretty snazzy. Here's an 80s word. That's pretty cool, because if I got 102 plus 103 plus 104, notice it's 3 consecutive numbers. Instead of adding them up, I can just take the middle number, 103, and multiply it by 3 very quickly. 309, instead of adding those up. Okay? So, anyways, pretty cool. So the conjecture is, if you look in the book at 14, I'll read it to you. 14 says, the sum of 3 consecutive integers is always 3 times, and what would you put? It's always 3 times the middle number. 3 times the middle number. Okay? Boy, I hope this is making sense. Number 15. Now, number 15 says, in the shapes below, the diagonals are drawn in blue. Write a conjecture about the number of diagonals of the next 2 shapes. All right, let me help you with this, okay? All right, there's no diagonals I can draw here. I can draw 2 diagonals here. And let's see, I can draw 1, 2. Then I can go here, 3, 4. Then I can go here and I can go 5. That's it. All right, here I can go 1, 2, 3, 4, 5, 6, 7. Did I miscount somewhere? Oh, here's one. Oops. Oops. Don't want that. 8. And there's one more, I believe. 9. Okay. Now, I know, students, in case you think Mr. Aris kind of went off his rocker, I know that we had all the lines, the numbers already written here below, but I just wanted to show you. So this is a 5-sided figure. This is a 6-sided figure. So notice for a triangle, there's 0 diagonals. For a square, there's 2 diagonals. For a pentagon, it's a 5-sided figure. There's 5 diagonals. And for a hexagon, there's 9 diagonals. Okay? That's a 6-sided figure. So how many diagonals would a 7-sided figure have? And how many diagonals would an 8-sided figure have? We're going to try to figure that out using a conjecture and just a pattern. Well, do you not see the pattern here? I went from 0 here to 2. So I added 2. Then I went from 2 to 5, so I added 3. Then I went from 5 to 9, so I added 4. So I added 2, then I added 3, then I added 4. So next, I would add 5, and 9 plus 5 would be 14. So a 7-sided figure has 14 diagonals. And now what did I add? I added 2, then I added 3, then I added 4, then I added 5. So now I would have to add 6 to this one, and an 8-sided figure would have 20 diagonals. That's the pattern, and that's the conjecture I'm coming up with, okay? I saw a pattern, and I gave my opinion, a conjecture, okay? Let's go on to numbers 17, 18, and 19. Show the conjecture to be false by finding a counterexample. So for 17, 18, and 19, we're looking for a counterexample. Now, I didn't, of course, write number 17 in the book. There's no drawing. You can read it with me. Number 17 says, if the product of two numbers is positive, then the two numbers must both be positive. Well, students, that's just not true. I mean, yes, if I take two positive numbers, 2 times 5, I will get out a positive number, 10. But hold it. If I take a negative 2 times a negative 5, I will get out a positive 10. So that's a counterexample. Look what it says. Read it again. If the product of two numbers is positive, so here's my product, it's positive, then the two numbers, right here, these two numbers, must both be positive. And that's not true. I just used two negative numbers to get out a positive number. That's my counterexample. Now, obviously, there's many more you could use, infinite amounts, but that's one counterexample there. All right, number 18 says, all rectangles with a perimeter of 20 feet have the same area. So, here we go. I'm going to give you a rectangle that has a perimeter of 20 feet. Are you ready? Here we go. Let's go 8 and 12, that'd be 4 and 6. Okay, I'm going to call this 4, this 4, this 6, and this 6. Is the perimeter of that 20? Well, let's see. The perimeter would be 4 plus 6 plus 4 plus 6. You add up all the sides, and it equals 20. Okay, very good. So my perimeter is 20. What's my area going to be? Well, length times width. So my area is going to be 24. All right. Now let me get another rectangle up here for you. Let's go with what I say, 12 and 8. Let's go with I know I got a better idea than that. Let's go with a square. Not the best square, but you get the idea. Pretend it's a square. All right, I'm going to say we have a length of 5, a length of 5, a length of 5, and a length of 5. Okay, what would the perimeter be? Well, the perimeter would be 5 plus 5 plus 5 plus 5, which would be 20. What would the area be? Well, 5 times 5 equals 25. Well, there's your counterexample right here. Let me read it to you. All rectangles with a perimeter of 20, and notice this rectangle here has a perimeter of 20, and this rectangle here has a perimeter of 20. All rectangles with a perimeter of 20 have the same area. Well, no. Here the area is 24, here the area is 25. That's not true. There's your counterexamples. All right? Or counterexample. Number 19. If two sides of a triangle are the same length, then the third side must be shorter than those two sides. Absolutely not. It's so easy to prove wrong here. Okay, let's just make it like this. We'll say, put it really almost flat there and there. We're going to say those are the same length of 3 and 3. And then draw this third side here. There's no way that that third side is shorter than these two sides here. Let's look at the conjecture. The conjecture says, now listen to me carefully, number 19. I'm reading out of your book. If two sides of a triangle are the same length, okay, I've got that, length of 3 and length of 3, then the third side must be shorter than these two sides. No way. That third side is longer than these two sides. So there is a really good counterexample. Now, that comment, number 19, is true sometimes. I could put a triangle going straight down, call them both a length of 6, then put a little side here. And then this side right here is definitely shorter than these sides. It's true sometimes, but it's not always true, okay? Well, I hope you guys are doing well, and I hope these homework videos are helping you. Don't give up. Work hard. You know it's not going to be an easy class, but work hard, do the homework, and you can do well if you'll do that.